Right now, we're talking about splitting an equation, which is this little question type that seems so harmless, but can be anything but. Now, this question type has certain characteristics. To identify it, you want to look for linear expressions on both sides of the equal sign and talk about the number of solutions. Now, linear expressions, which means x and y are to the first power, on both sides of the equal sign, that's actually quite common. But combining it with the talk of the number of solutions and just generally seeing the appearance of the questions in this video, and you should have a good idea of when you're seeing this situation. So it would look something like this. Ax plus b equals 5x plus 2 has infinite solutions. And then you'll be asked a question like, what's a plus b, or something like that. Now, what you want to do is give each side of the equation its own y equals equation. So you're splitting it into two separate equations, hence the name. Y equals ax plus b and y equals 5x plus 2. Now, the logic behind this is that if you were asked to find the intersection of two functions, what we would usually recommend is setting them equal. This question is the same thing in reverse. It's the opposite. You already have these two things set equal, and now you have to make some sense of it. So let's try an example. Here, we have linears on both sides of the equal sign. Linear because there's no x squared. There's nothing squared in here. And we're being asked about the number of solutions because we're being told that it has infinitely many. Now, all of the questions in this type are variations of the number of solutions for two lines, which, by the way, is what our last video was about. And two lines can have one solution, no solutions, or infinite solutions, depending on the slopes and y-intercepts. If the slopes are different, then the two lines will hit once. If the slopes are the same and the y-intercepts are different, then you'll get parallel lines that never hit. That's no solutions. And if the slopes and the y-intercepts are the same, well, the lines occupy the same space. So technically, they're always intersecting, and they have infinite solutions. So coming back over here, when we hear that there are infinitely many solutions, that means that the slopes and the y-intercepts must be equal. So let's represent this as two separate equations. Y is 2x plus 16, and y is ax plus 8a. So I took the liberty of distributing here because that had to be done anyway. But now both of these are in y equals mx plus b format because the part that has the x, that's your slope. So the slope here is 2, the slope here is a, the y-intercept here is 16, the y-intercept here is 8a. And the slopes and the y-intercepts are equal. So it's going to advantage us to set the y-intercepts equal. 16 equals 8a, divided by 8 on both sides, and a equals 2. Now trying another example, we're obviously going to be going slightly upward in order of difficulty with each question. So here we have two linears on both sides, and we're being asked about the number of solutions. So let's follow our process, set them equal to their own individual y equals expressions. So this one here, if we just distribute right now, we'll get y equals 120x minus 96. And for this one, we'll have y equals negative 96 plus 120x. And that one we can rearrange into y equals mx plus b. So y equals 120x minus 96. So this equation here is what we had on the left. This equation here is what we had on the right. It's all a little confusing because they're identical. But once again, when you're dealing with the number of solutions for two lines, if they're identical, that actually means something. That means that you have the same slope and y-intercept, infinite solutions. So for us in this question, they're identical. We have infinite solutions, and that's answer choice C. Now going on to this question. This is another variation where it's even a little more weird because you don't have any variable on this side. But we can follow the same program because technically it's linear by the fact that there's no real exponent. So even if it's just the number 12, the number 12 is a linear expression. If I had y equals 12, I'd have a horizontal line. So let's follow our regular process. For the left-hand side, we have y equals b plus 3x. And while I was tempted to go ahead and distribute that right now, it's actually better not to because this is your mx plus b. And the b is the fact that there's nothing there at the end. There's a 0 there. So the y-intercept for this part would be 0. Now let's take the right side, y equals 12. But if we want to force that into y equals mx plus b, we'll think of it as y equals 0x plus 12 because there is no 0 term. And that actually means in your y equals mx plus b format that the slope is 0 here and the y-intercept is 12. Here on the top equation, the slope is b plus 3 because whatever's in front of x, that's your slope. So we have no solution. Back to this graph here, no solution is this one where you have two parallel lines. And that means that the slopes have to be the same, even though the y-intercepts have to be different. So let's set the slopes equal. The slopes have to be the same. B plus 3 has to be equal to 0. Therefore, b is -3, and that's answer choice A here. And now going to our next question. Once again, we have linear expressions on both sides of the equal sign, and we have a conversation about the number of solutions. So our process is to set the left and the right both equal to their own y equals. So y equals c5 minus x plus d. And on the right side, y equals 3 minus x. Once again, the logic is that if the question started with these two and asked you to find out where they intersect, the correct instinct is to just set them both equal to each other. In this question, they're already set equal to each other, and so we're actually doing the opposite. We're separating them. Now we're trying to get them into y equals mx plus b format. So let's distribute that c. Y equals 5c minus cx, so we distributed, plus d. To now get it into y equals mx plus b format, we need the x toward the beginning. So y is -cx plus 5c plus d. And so this is y equals mx plus, and all of that is the b because it lacks x. Now coming to the other one, if we want that in y equals mx plus b format, we can just reverse the order, -x plus 3. So that's y equals mx plus b, with the slope being the -1 in front of the x and the b being 3. So this has to have infinitely many solutions. So leaving what we did before, infinitely many means they're identical, and the slopes and the y-intercepts must be the same. So what does that mean for us here? Well, for the slopes, the slope on the first one is -c. The slope on the second one is -1. So -c equals -1, and c is 1. That means that we would stick with A or B. Now, the next part, the y-intercepts. One y-intercept is 5c plus d, and the other one is 3. So let's write that out. 5c plus d equals 3. And guess what? We know what c is. So 5 times 1 plus d equals 3. In other words, 5 plus d equals 3. Take away 5 from both sides, and you get -2. So the correct value for d was -2. And our answer here is A. Going to the next question now. Once again, linears on both sides of the equal sign, and a conversation about the number of solutions. So, following the process, we'll say y equals the left side, b, 2x minus 4 plus x, and y equals the right side, 5x minus 3. So now we're cleaning this up in order to get it into y equals mx plus b. And really the idea is to group everything with x in one area. So let's start by distributing y equals 2bx minus 4b plus x. Rearrange it so the x's are together. 2bx plus x minus 4b. And now we'll factor out x here because that gives us our mx plus b format. So these two terms both have x's, and if you're factoring out the x, you'll be left with 2b plus 1 minus 4b. So now we have our y equals mx plus b. And it's a little extra confusing because we have the letter b, but there's also the b, that's the y-intercept. So two b's here that mean two different things. And the other one's nice and easy. Y is 5x minus 3. So our two slopes are 5 and 2b plus 1. And our two y-intercepts are -3 and -4b. Well, no solutions is this scenario here, where because they're parallel, that means the slopes are the same and the y-intercepts are different. So let's use that. The slopes have to be the same. So the slope on the left, 2b plus 1, must equal the slope on the right, 5. Take away 1 from both sides, 2b equals 4, divide by 2, and b is 2. That's all the question's really asking us, so we didn't really have to get into the y-intercepts. So b is 2, and the answer here is D. Now, we had to bring in this question because it has a really interesting twist. All along for no solutions, we've been saying the slopes have to be the same and the y-intercepts have to be different. But rarely are you asked to prove that you understand that the y-intercepts are different. Now, the digital SAT really does seem to get harder every time. So some of these nuances are exactly the things that you need to understand to be ready for a test. So here in this one, we have our same linears on both sides, and we have no solution. Once again, slopes have to be the same, y-intercepts have to be different. So let's start by splitting them up. Y equals 8x plus 7, and for the other, y equals cx plus cd. So I just went ahead and distributed while splitting it up. No solution, slopes are the same, y-intercepts different. So the slopes are the same, that part's easy. X is equal to c, because this is our y equals mx plus b here. This is our y equals mx plus b here. And the slopes are the same, so c is equal to 8. But the y-intercepts being different, that's interesting here. Well, the y-intercept here is 7. The y-intercept here is cd. So what we're saying is 7 must not be equal to CD. What I'm doing right now, or what I'm going to do, is I'm going to use this not equal sign as an equal sign. In other words, use it as the basis for some algebraic steps. So by the way, we already knew C was 8. So 7 is not equal to 8D. And if we had an equal sign here, instead of a not equal sign, the next thing to do would be to divide both sides by 8. And so let's treat it just like that. Let's divide both sides by 8. And what we'll get is D is not equal to 7 over 8. And that's what we have right here. D is not equal to 7 over 8. So we found out that C was 8 and D was not 7 over 8. And so the answer here is D. We hope this video helped you to get that much more ready for your upcoming SAT. Do us a favor and tell all your friends who are preparing for the SAT and everyone at your school about this amazing resource. We're going to be adding new lessons almost every day. Thanks so much.